हम लोग हाई स्ट्रेंथ डिफॉर्म बार यूज इन कंक्रीट स्ट्रक्चर के डिफरेंट ग्रेड के बारे में स्टडी कर चुके हैं। अभी इस वीडियो में रोलिंग मार्जिन क्या होता है, जो स्टील का स्टैंडर्ड वेट दिया गया है ISO 786 में, या हम लोग उसके डेंसिटी से फाइंड आउट करते हैं, तो उसका और जो एक्चुअल प्रोड्यूस्ड स्टील है उसके बीच का जो क्वांटिटी डिफरेंस होता है, दैट इज नोन एज ए रोलिंग मार्जिन। वो कभी ज़्यादा होगा, कभी कम होगा, कभी स्टैंडर्ड के बिल्कुल नज़दीक होगा, और डिपेंडिंग ऑन मैन्युफैक्चरर एंड प्रोड्यूसर्स इस्टेब्लिशमेंट वो कैसा प्रोड्यूस कर रहा है। जब से फार्म बार प्रोड्यूस होने लगे हैं, देयर इज लिटिल वेट डिफरेंस होता ही है, तो उसको IS कोड में एक लिमिट दिया हुआ है कि यदि वो अब 10 mm हो तो कितना प्लस माइनस एडमिसिबल है, यदि वो ओवर 10 mm टू 16 mm हो तो प्लस माइनस कितना होना चाहिए, ओवर 16 mm है तो प्लस माइनस कितना होना चाहिए। इस तरह से उसने IS कोड में उसकी लिमिट दे दिया है। सो प्रोड्यूसर कैन produce their steel within the specified limit so that it can be acceptable at the site without any problem. Otherwise, if the limit is not given or limit is not specified, so there will be a lot of conflict between the purchaser and producer and the organization who are going to accept the steel. So to minimize all the conflict, acceptance limit is given, and we find out rolling margin, whether how much is the steel produced विद इन द एक्सेप्टेबल लिमिट के बाहर हो गई तो उसको रिजेक्ट ही हो जाती है, एंड विद इन द एक्सेप्टेबल लिमिट है तो कितना प्लस और माइनस है, और प्रोजेक्ट पे इसका कास्ट इम्प्लीकेशन क्या है, हाउ टू एकोमोडेट दीज इम्प्लीकेशंस। ये जो कॉन्ट्रैक्टर जो मेच्योर कॉन्ट्रैक्टर हैं वो ऑलरेडी उसको अकाउंट फाड़ करके 3 से 4% रखते हैं, सो दैट इट डजंट गिव द सरप्राइज टू द प्रोजेक्ट। लॉसेज कम करता है इफ यू नो अबाउट द रोलिंग मार्जिन। So rolling margin, it is the ratio of difference in actual quantity, actual weight, and standard weight to the standard weight. हम लोग एक्चुअल वेट पर मीटर निकाल लेते हैं, फिर उसका स्टैंडर्ड वेट उसमें घटाते हैं, उसके बाद स्टैंडर्ड वेट से उसको डिवाइड करते हैं। इट इज एक्सप्रेस्ड इन द परसेंटेज and expressed in the percentage. So rolling margin is nothing but actual weight minus standard weight upon standard weight. स्टैंडर्ड वेट IS 178 में टेबल 1 में दिया हुआ है। जनरली टू अवॉइड द कॉन्फ्लिक्ट वी शुड यूज दोज स्टैंडर्ड वेट्स ओनली फॉर डिटरमाइनिंग द रोलिंग मार्जिन। इफ table is not available along with, then we can also find out by weight per meter by using the formula d square upon 162, which is derivative of the formula already given in the class 6 of the IS 1786. Area of cross section is equal to weight divided by 0.00785 length. Weight and length is in kg to the precision of 0.5%, and length is also in meter to the precision of 0.5%. So we can utilize this formula to find out the standard weight. So we get almost 99% accurate result from this also. So standard weight given in the table 1 of IS 1786. Dia of bar we generally use in the field 8 mm, 10 mm, 12 mm, 16, 20, 25, 28 and 32. So we should know the standard weight of all these dia which is being regularly used at site. So 8 mm is 0.395 kg per meter, 10 mm is 0.617 kg per meter, 12 mm is 0.88 kg per meter, 16 mm is 1.58 kg per meter, 20 mm is 2.47 kg per meter, 25 mm is 3.85 kg per meter, 28 mm is 4.83 kg per meter, and 32 mm is 6.31 kg per meter. It is given in the IS 1786 table number 1. So all we can take provide the conflict as a standard weight. Otherwise, we can also find out for any dia, say dia 10, so it will be 100 divided by 162 for 10 mm dia. So weight per meter will be 100 divided by 162 equal to 0.617. So likewise, we can find out weight from d square upon 162 and keep feeding the this table. And after that, any dia at the site, if you see 10, 20, 12 in a mass, so we can take CC sample of each dia from the bundles and measure it, and after that deduct the average weight minus standard weight divided by standard weight, we get the rolling margin. So the tolerances given in IS 1786 class 7 tolerances of different dia steel is given in the IS 1786 up to including 10 mm is plus minus 7%, plus minus 7%, over 10 mm and including 16 mm it is plus minus 5%, over 16 mm it is plus minus 3%. This is already given in the IS 1786. We will be utilizing this with, to know whether the received steel at site is within the limit or it is outside the limit. If it is outside the limit, the rejection is there. If it is within the limit, then steel has to be accepted and used consumed in the project. So if we say size here 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, 25 mm, 28 mm. So for 8 to 10, for this range 8 to 10, the tolerance is given plus minus 7%. If it is in minus side, the weight per meter will be less. So underweight, we get more length. So this is up to say, and for 8 mm the standard weight is we just seen in the previous slide, it is 0.395. For 10 mm it is 0.617. For 12 mm it is 0.888. For 16 mm it is 1.58. For 20 mm it is 2.47. For 25 mm it is 3.85. And for 28 mm it is 4.83 kg per meter. So if we receive steel which is weighing say 10 mm steel which is weighing 0.607 kg per meter, so it will be underweight. If it is weighing 0.628 kg per meter, it will be overweight. Then we determine how much it is overweight, how much percentage, or how much it is underweight. So -1, -2, -3, -4, -5, -6, -7. So it may be minus 2.1% in this range or in this range or in this range. Wherever it is lying, we know how much severe the steel received is. If say it is 1% or 2% at underweight side, designer may accept, but if it is minus 7%, so designer may not accept because it may be harmful to the structure, because the area of steel is calculated for designing the structure. So if even though the steel received at site is within the permissible limit, but if rolling margin is more, say about 7%, then it has to be referred to the designer whether it is acceptable or not. So for this two dia is this minus 7, minus 6, and plus side, if it is overweight, plus 1, plus 2%, plus 3%, plus 4%, plus 5%, plus 6, plus 7. So it can range from the minus side to minus 7% and plus side to plus 7%. So this is for 8 and 10 mm. For 12 and 16, it is a 5%. So minus 1, minus 2, minus 3, minus 4, minus 5%. And on the plus side, it will be plus 1%, plus 2%, plus 3%, plus 4%, plus 5%. So the same case goes here also. If we receive 12 mm on dia bar and 16 mm dia bar, and it is say 1 or 2% plus or minus, then it is acceptable. Nobody will raise a question. If it is say minus 5%, plus 5%, plus 5%, it will be a lot of loss to the contractor, because a higher dia, as we go to higher dia, weight per meter give the less length, and it is very costly for the contractor who is using it. Over 16 mm, it is plus minus 3%, plus minus 3%. So minus 1, minus 2, minus 3, plus 1, plus 2, plus 3%. We should avoid getting the steel of bigger rolling margin. As nearer to the standard weight, that is good steel, said to be good steel. So again, rolling margin is actual weight subtracted by standard weight, divided by standard weight into 100. So we will be taking we can, if say 10 mm dia bar, we received the weight is 0.60 kg per meter, received weight is, and for the same dia standard weight is 0.617. So we can put the 0.60 minus 0.617 divided by 0.617 into 100. This will be the rolling margin of this particular lot which has been received at site. So 0.60 minus 0.617, so minus 0.17. Divide by 0.617. So 0.017 divided by 0.617 equal to 0. Into 100 into 100. So it is 2.75%. It is minus 2.75%. So the steel received is in negative side, hence it is underweight, underweight steel, and we get the more length of the steel. Sometimes it is good for the contractor getting more length, but it is not good for the structure. So rolling margin is actual weight minus standard weight divided by standard weight into 100. Let us solve on question 100 metric ton of 16 mm dia bar is procured. The weight of rebar is found to be 1.63 kg per meter. Find out the tolerance and the length of bar received at site. So 100 metric ton of steel has been procured, and in laboratory determination it is found average weight of cedar must have been taken, and the average weight is found to be 1.63 kg per meter. So find out the how much what is the rolling margin, tolerance क्या है, and length क्या है. So from the prima facie for 16 mm 16 mm dia bar standard weight is 1.58 kg per meter, and steel received is having 1.63 kg per meter. It means it is more than 1.58. So it is overweight steel. It is a overweight steel, and the length received will be less than the actual. So, and this is the standard weight, and procured steel is having weight per meter 1.63 kg per meter. So what is tolerance? Tolerance is given by actual weight 1.63 minus 1.58 divided by actual weight 1.58 into 100. So this is nothing but 1.60 minus 1.58 is 0.05 upon 1.58 into 100. So we get 0.05 divided by 0.05 divided by 1.58 standard weight. So it has come 0.0316 into 100, say 3.16%. So it is in plus 3.16%, and dia bar is over 16 mm. For the 16 mm it is 5%. So the range has come to this limit, 3.16%. So it is acceptable. Still received is so we found it is 3.16%, and for 16 mm, for up to 16 mm dia bar, the limit is plus minus 5%, and the received steel is 3.16% on the plus side. So received batch of the steel at site is acceptable. So this is how we maintain the record at site. How when different die of steel has come to the site, we take randomly from each bundle 3 number of samples. Say for 8 mm we received, 10 mm we received, 20 mm we received. So we say we received 20 mm die bar. We received 20 mm die bar from XYZ supplier. So we record here supplier name XYZ, and the date of receipt, say we received on 20th of March. 20th of March we received from XYZ supplier a quantity of say 100 metric ton steel of 20 mm dia. All this record has to maintain by store department. Who is the supplier, what is invoice number, what is baby slip. All this record is maintained in the store in every company. So for engineering purpose, we must have some little extract from or some ID number from the store what is the ID number of that particular lot, so that we can find out the other results which is of interest to the engineer. So say dia bar received is 20 mm, length of sample say 1.2 meter. Some sample is 1.35, 1.2, 1.15. All L1, L2, L3. We take the sample, measure it with 0.5% accuracy, and after that divide by 3 and find out the average length of that, which is 1.2. And also we determine the weight of sample. All the 3 samples will be having different weight. We record that weight also, and the average weight of that sample also taken. Divide by 3 if 3 samples are there. So say we found it is 2.94 kg. So after getting this average length of 3 samples, average weight of 3 samples, then we find out the weight per meter. So 2.94 divided by 1.2 will give the weight per meter. So 2.94 divided by 1.2 equal to 2.45. So 2.45 kg per meter. And the standard weight of 20 mm dia bar we know it is 2.47 kg per meter. So we record the standard weight as 2.47 kg per meter. So rolling margin RM is the measured weight, actual weight. Actual weight is 2.45 minus the standard weight 2.47 divided by 2.47. So it will be minus 0.02 upon 2.47 into 100. So 0.02 divided by 2.47 into 100 equal to 0.8%. So it has come to 0.8%, and limit for this 16 mm over is plus minus 3%. So it is minus 0.8%. So it is underweight. Difference is underweight, and it is 0.8%, far less than the minus 3%. So it is acceptable, and the bar received at site is in good condition, and there will not be much loss to the contractor. And the length. So we ordered 100 metric ton, 100 metric ton of 20 mm dia, whose length is 2.45. So 2.45 kg per meter is 100 metric ton into 1000. So length we can find out the length. 100 divided by 2.45. So length will be 40,816.32 running meter. If actual standard length should have been 100 into 1000 kg divided by 2.47. So standard would have been divided by 2.47. Standard is 40,485.82 running meter. So the difference between this 40,816, and whereas with the standard it would have been 40,000 6,485 running meter. More steel has been received at site, and it is good for the contractor. And since tolerance is very marginal, 0.8%, so it is good steel, we can say, and it is acceptable. Here also we found 3.16% in 100 metric ton, since its weight was 1.63. So here we can find out how much length reduction is there, because if we get the overweight steel, then we will receive the less length of the bar, because it is universally proportional. So 100 metric ton into 1000 divided by kg per meter, so it is 1.63. So it will be divided by 1.63 equal to 61,349.69 running meter. We received at site 61349 running meter, whereas if standard weight, which is for 16 mm dia 1.58, if standard weight according to standard weight we should have received the length of 1 lakh. हम लोगों को डिवाइड बाई 1.58, तो स्टील 66,291.13 रनिंग मीटर मिलती यदि स्टैंडर्ड वेट से प्रोड्यूस हुई होती और हमको साइट पर मिलती. सो दिस इज विद द received steel length, and standard से होता है say L1 L2 100 into 1000 divided by 1.58, so it will be 63291.13. हम लोग स्टैंडर्ड जो कि एस्टिमेट किया गया था साइट पे, उसके हिसाब से 63,291 291.13 रनिंग मीटर की स्टील मिलनी चाहिए थी. उसके अगेंस्ट में ओवरवेट होने से 61,349 लेंथ मिली. तो लास्ट इन द लेंथ हुआ 6291.13 माइनस 61349 इक्वल टू 1942 रनिंग मीटर का लॉस हुआ. एंड in terms of weight, if we multiply by 1.58, so 3068 kgs loss of weight. Loss of weight is nothing but the additional procurement. Now the contractor or person who is utilizing it has to procure additionally 3068 kg, about 3 metric ton more steel, which is lost to him, which he might have not considered during his execution of the project. So it is very important, because steel pays a lot of it is one of the costliest material in construction. So an engineer has to be very careful while placing order, setting the specifications to the producers or suppliers कि how much rolling margin is required. यदि इससे ज़्यादा होगा तो what is the course to be taken in the contract or subcontract. It has to be well defined. So knowledge of rolling margin is very important for a field engineer. In next video, we will be studying about the physical properties of steel. Thank you.